Great, thank you very much for that presentation. I believe in addition to Sang-Min, some of his co-authors are also available to answer questions. Let me start, why don't I start the Q&A off by asking a question. So in your talk, you primarily focused on efficient shard management during planned events, where you have time to run a solver for maybe a minute to determine the right shard placement. Can you tell us a little bit about how the system handles unplanned outages?
Okay, yeah, so to repeat your question, the question is how shard manager handles unplanned failure. Is that correct?
That's right, yes.
Yeah, so I think shard manager handles those random failures pretty much similar to other systems. So we have we rely on Zookeeper to detect the application server's failure, and once we detect such failure, yeah, we try to find the new allocation for the shard on the server, and those allocation happens in emergency mode. So our focus in that scenario is to find the new allocation as soon as possible, even though it's not optimal. Then we allocate the new shard to the new available servers and migrate the shard to those new servers.
I see. So there's an emergency mode where you're less concerned about meeting all those constraints and more about just ensuring availability.
Great. That's correct.
Okay, great. Thank you. I think we have a live question from Rohan.
Hello. Hi. Nice work. So my question was, so my basic question is like, how does like the shard manager work in the overall picture with respect to Facebook services? And what I mean by that is that, do the applications themselves decide how big they want their shards and so on, and create their own shards and then use the shard management service for movement of the shards? And if this is the case, then are the reads and writes of these applications also forwarded to the shard manager to find out where the shard is placed for answering requests?
Yeah, okay. Yeah, I think that's a great question. So basically, the shard manager's approach sharding abstraction is to, I think that there are different systems, for example, the Slicer and Azure Service Fabric, which it takes us to some different approach on sharding model. In shard managers, we actually delegate the partition of the key space into shard to the application. So application get to provide us a list of shard, and application maintains a key space to shard mapping. And then, we have our, and the next part of the question was, how the request is served once shard is deployed. And shard manager is a control plane system, and we are separated from data plane. And once shard manager generates a shard map, we distribute that shard map through our dedicated distribution component, so that the application typically get to learn about which server to contact through this shard map. So application can directly send the request to the server hosting those shards. Does it answer your question?
Yeah, that does. Thank you.
Great. I think Sudon has a live question.
Yes. So my question is that does the shard manager allow users to specify highly customized management logic for like different application shards depending on the application characteristics? So like something similar to the customer resource definition in Kubernetes.
I think so. Your question is whether the shard manager allows application to specify how application handles each shard.
Right. Like basically just highly customized logic.
Okay. So I think one part there's two aspects here. So one aspect is the shard manager is oblivious to what actual the data content is. The only thing shard manager care is given the list of the shard, and it only generates the assignment from shard to server, and then it uses a request routing platform to route the request to the server that hosts the shard. And actual this request handling part is all delegated to the application. And on the other hand, also shard manager but allows the application to specify various constraints on placement of the shard. So application can specify certain type of shard or certain list of the shard should be placed in certain region where they shouldn't be, and some replicas has to be in spread across different fault domain and so on. So, does it answer your question?
Yes. Yeah. Thank you. Thank you.
Thank you.
Great. I don't see any additional questions. So yep, great. So we'll move on to the next presentation. So our next presenter is Yang Chen. Thank you. Our next presenter is Yan Chen. He's a principal researcher in the Beijing lab of Microsoft Research Asia. His research interests include decentralized systems,
Hi, okay. I think there are several of the authors here with us, and let me see, do we have them all promoted?
Yeah, I think so. Yeah.
Okay, great. Okay, yeah, so Inhoi, why don't you go ahead?
Yeah, sure. Hello, I'm Ino from NUS. Thanks for the great talk. I have a short question. If I understood correctly, the presentation at the middle of the talk, it mentioned that the planned was it
Yeah,
planned
operation.
update? Yeah, planned
Yeah,
operation it have more longer downtime for the performance compared to the unplanned operations. Is it correct? Did I understand correctly?
I think, yeah, we mentioned that the planned operation is about 1,000 times more frequent than unplanned failure.
Frequency, I see.
Yeah.
So this work is applicable for the planned operation only, but not for the unplanned operations?
Yeah, so the word characteristic is, so the difference between our system and the previous similar system is, yeah, we treat the planned operation differently than unplanned operation. Many of our previous system treats planned operations with the same mechanism to treat the unplanned operation.
I see.
So, but by treating the planned operation more gracefully and proactively, yeah, we can guarantee more application availability.
I see. So is it because the planned operations is literally planned and the operator can know in advance before it happens, but unplanned is unexpected event, right?
Yeah, and another technique is, yeah, we have this test control API that allows our system to communicate with the underlying cluster management system. Yeah, so that we can get notified about any planned operation, such as maintenance or software update, so that we can react to it proactively.
I see. Thank you. Yeah.
Okay, Hao, go ahead. I think you've been promoted. Here, introduce yourself.
Yeah, sure. Hi, this is Hao from Huawei. I have a question regarding to this wonderful work, and basically how you separate the shard management with the consistency of the data state for each shard. Is there any kind of management or guarantee that this shard manager will check so that when the shard move to the other position or place that still can be successfully or consistently loaded, or at least the cost of that consistency check is manageable?
I think, yeah, that's a very good question. So I think it is described in paper, but yeah, I can give you some short summary on that. So Shadow Manager models application in 3 ways. One is primary only, and then secondary only, and multi-role. And in each of them, we provide a guarantee that there will be only one primary replica. So in primary only services, we guarantee that there will be, in shadow map, there will be only one replica assigned to a server. So application will see only one replica in that. And similarly, in multi-role, we also provide a guarantee that among many replicas, there will be only one and most one primary role in that. So that way, the application may provide a strong guarantee. And one of the example application is for our backend databases system is implemented and modeled as a multi-role, and then they implemented the Paxos protocol so that they can provide both strong consistency and high availability at the same time. So some of them maybe provide this strong guarantee on single primary, and then rest of them can be implemented on application. Does that answer your question?
Yeah, in one, I think at least in one dimension. The other dimension I'm also interested in is that is there any interaction between the control side and the data consistency side?
Yeah, I think the.
Besides preventing the multi-primary issue, and is there a clear state when you move a partition, right? When you move a shard, that you want this shard to be in a clear state before it being moved, right? Or at least you are able to clean up the state.
I see. Yeah.
Reload it. Yeah.
Yeah, I think that's if I understand the question correctly, how Shadow Manager can interact with the application to ensure such kind of ordering guarantees while migration happens. So the API between application and Shadow Manager is described in paper, but yeah, it's a simple that whenever we migrate the shard, we make a RPC call to application server, either a drop shard or the add shard. So whenever and then we make a call in our order such that we first try to drop the shard on the current shard on the server that currently holding the shard. So when we try to move the shard, we first make RPC call to that server. Okay, now you need to drop the shard. And then once that application acknowledges that it cleared up the shard on that server, then Shadow Manager will trigger another RPC call to a new server that, okay, now add this shard on your server. So that way the application can ensure that there's only, you can react to the shard deletion and addition, and also ensure that there's one shard data available in their application.
Thanks. I think I will read the paper for more details. Just giving back the time to the committee.
Yeah, this is a great conversation, but yeah, we should move on to the next paper. And maybe if we have some time at the end of the 3 talks, we can go back to having more discussions. All right, so our next paper is called Forerunner. It's a